We're going to use the definition of the derivative to differentiate the sine of x function. This is a very important derivative. Every student of calculus should know how to do that. Recall the definition of the derivative is f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. Before we differentiate this function, we're going to need several preliminary results, and here they are. The first one is this trig identity. I'll use x and h instead of a and b that's normally used. Sine of x plus h is equal to sine of x times cosine of h plus sine of h times cosine of x. The second result we're going to need is the limit as h approaches 0 of sine of h divided by h is 1. This was shown in an earlier video, so you can take a look at that one if you don't know how to derive it. And the third result we're going to need is another limit, which is the limit as h approaches 0 cosine of h minus 1 divided by h equals 0. I'm going to derive this since this was not shown in an earlier video. So let's derive this result. When evaluating limit as h goes to 0 of cosine of h minus 1 over h, we plug in 0 for h. The numerator is cosine of 0 minus 1, which is going to 0. Similarly, the denominator is going to 0, so it's an indeterminate form, 0 over 0. We have to eliminate that to find a finite result or show that it's infinite. Since we already know it's 0, this is not 0 over 0 is not 0. It's an indeterminate form. So here's how we proceed. We're going to take our limit as h goes to 0, cosine of h minus 1 over h, and multiply it by cosine of h plus 1 divided by cosine of h plus 1. So this is just 1. Didn't change the problem. The limit now becomes the following. Limit h goes to 0. The numerator is cosine squared of h minus 1, and the denominator is h times cosine of h plus 1. Now, from the trig identity, sine squared h plus cosine squared h equals 1, we solve for cosine squared h minus 1, and that's minus sine squared of h. So that's what we're going to do. We're going to replace the numerator with minus sine squared h. Now we can factor the minus out. The limit is now limit h goes to 0, sine squared h divided by h times cosine h plus 1. And let me rewrite it this way. Limit h goes to 0, sine of h times the sine of h divided by h times cosine of h plus 1. And one more step. Let's rewrite it as two limits. So this is minus the limit h going to 0. The first limit is sine of h over h. The second limit is limit h, of course, going to 0, sine of h divided by cosine of h plus 1. Now the first limit is 1, and the minus in front makes it minus 1. And then plugging in 0 for h, the numerator is 0, the denominator is 2, and this is perfectly okay. It's not an indeterminate form. This is equal to 0 as was stated earlier. So now let's get back to the derivative of the sine function. We're going to do it in 4 steps. The first step is to express f of x plus h, which in this case is sine of x plus h. We are going to use the trig identity listed above. It is sine of x times cosine of h plus sine of h times cosine of x. That's the end of step 1. Step 2 is to take step 1, f of x plus h, subtract from that f of x. So in our case, it is sine of x cosine of h plus sine of h times cosine of x minus f of x, which is sine of x. Take a look at this. Here's the term has sine in it, and this one has sine of x, so we can factor sine of x out, and that leaves cosine of h minus 1, and then this term is untouched, so we write it as sine of h times cosine of x. That's the end of step 2. Step 3 is to take what we did in step 2 and put it over h. So it's f of x plus h minus f of x divided by h. And in our case, it looks like this. Sine of x times cosine of h minus 1 divided by h plus sine of h cosine of x also over h. There's nothing we can do here to simplify, and we should go to step 4. Step 4 is the computation of the derivative. F prime is the limit h going to 0, f of x plus h minus f of x divided by h. So in our case, this will be two limits. Notice that this right here, we have sine of x. It does not depend on h. And in this part, cosine of x does not depend on h. So we can factor sine x and cosine x in the two limits, put them in front of the limit. So it looks like this. We have sine of x times the limit h going to 0, cosine of h minus 1 over h, plus, and the second part, cosine of x goes in front. So cosine of x times the limit h going to 0, sine h over h. Well, that's when we use our preliminary results. We show that this limit is 0, and this limit right here is 1. So this is equal to sine of x times 0 plus cosine of x times 1. And that, of course, is cosine of x. So we just found the very important derivative of the sine function. To summarize, f of x equals to sine of x. Its derivative, by using the definition, is cosine of x. You'll be using this many, many times in not just Calculus 1, but in Calculus 2, Calculus 3, and then further courses beyond